Hi everyone, welcome to Mr. Wagid's math class. We will continue building on what we learned before about relations and functions. So let's review what we already know. A relation is a function if every input has exactly one output. We also learned an equation shows the relationship between two variables, the x and the y, or any other two variables. We know y equal mx plus b is a linear function where m is the slope, which is the number attached to the variable x, and b is the y-intercept, which is the number that stands alone, it's not attached to anything. Today's lesson, we will discuss something called linear functions. Linear, when graphed, makes a line. Function means every x, which is the input, has exactly one y value, which is the output. Put them together, then linear function is a function whose graph is a non-vertical line. So it did make a line, but as long as that line non-vertical. Why? Let's see why. Here's a graph with the red line crossing the x at 8. Watch how this first blue dot has a coordinate pair of 8, 8, where x is 8, y is 8. The second one is 8, 2, where x, the input 8, the output is 2. The last one, x equal 8, which is the input, but the output is negative 2. Watch how the x is 8, which is the input. It has multiple outputs, and there's a lot more than those 3 dots on the line. Therefore, not a function. So it is linear because it did create a line, but is it a function? It's not a function because the input 8 has multiple outputs. Which takes us to using that vertical line to test whether the graph represents a function. Now we're going to practice with those 3 graphs using the vertical line test to check if they represent a function. We all know it's not linear. It's not linear because they don't create a line. This is a circle, this curves, and this also goes 2 different ways. So it does not make a straight line, so we all know they are not linear. But are they function? Do they represent a function? If I draw a vertical line on the first one, then the vertical line crosses the graph at 2 points, which means the input negative 2 has 2 different outputs. One is 3 and the other one is negative 3. Therefore, it's not a function. Now let's discuss this. B, same thing, draw a vertical line. The vertical line crossed the graph at 1 point, which is negative 2, the input, the output is 1. Therefore, it's a function because every input has exactly 1 output. Now, the last one, draw a vertical line. It will cross the graph at 2 points, 2, 2, and 2, negative 2. Therefore, the input 2 has multiple outputs, which makes it not a function. This lesson will focus on a lot of real-life application instead of just giving you a graph and a table and use it to write equations. So the first example, use the graph to write a linear function. So it is a graph. It did make a line. I need a linear function, which is the equation that we talked about at the beginning, y equal mx plus b, because that is an equation when a graph makes a line. Here's a line. So we need to find m, and we need to, which is the slope, and we need to find b, which is the y-intercept. So I will leave this table to show you how do you find the slope and the y-intercept from graph. The slope is rise over run, and the y-intercept where the line crosses the y-axis. So let's start with the slope, rise over run. So choose 2 dots on the line. I am going to choose this blue dot on 0, 0, which is the origin. Now to the rise is going up. That means how did y change? But pay attention to what the y-axis is counting by. What's the scale? Am I going 1, 2, 3? Or am I going 25, 50, 75? Because what? The y-axis is counting by 25. So please pay attention to the scale. That's the biggest mistake students will do. So from 0 to 75, that's an increase in $75. Now the run is the x-axis from 0 to 3. That is an increase of 3 hours. So the rise is 75 over 3. If I simplify that, will give you 25. so the slope equal 25. Now the y-intercept, which is b, where did that line cross the y-axis? Right on 0, which means b equals 0. All you have to do, take those numbers and replace them in the equation. Y equal 25x plus 0. Now interpret the slope. The word interpret means explain in the contents of the problem, which means I am using the earning in dollars and the time in hours to explain what the slope is. Remember, the slope is a rate of change that shows the relationship between two quantities. And the quantities are $75, because that's the y, over 3 hours, which is the time. If I simplify that, remember it gives you 25. Again, if I make it a fraction, that means put it over 1. We're $25 over 1 hour. Now to explain or interpret the slope in words, you use the word per, every, or each. Use those words to explain what the slope is. So the manager B earns $25 per hour. Now interpret the y-intercept. Again, the word interpret means explain in the contents of the problem. So I want to know, what does that 0 mean in the context of the problem where the manager is earning dollars per hour. The y-intercept B is 0. Use the word initial, starting, or beginning to explain the y-intercept. So the initial earning is $0. He started with $0 and then he started making $25 per hour. Here's another example, but this time we're using a table to write a linear function. A bunny hop is a bike trick in which the rider brings both tires off the ground without using a ramp. The table shows the height y in inches of a bunny hop on a bike that weighs x pounds. Write a linear function that relates the height of a bunny hop to the weight of the bike. So what's happening to the height of the bunny hop every time the weight changes? Here's the table. To write a linear function means to write an equation, y equal mx plus b. Again, this is the different ways to find the slope and the y-intercept, but this time is from a table. To find the slope from a table is the change in y divided by the change of x. Now look at the table. How did y change from 10.2 to 9.8 to 9.4? It went down by 0.4 inches. Now, how did x change? Or delta x means the change in x. How did x change from 19 to 21 to 23? It increased by 2, which means the height of the jump in inches decreases by 0.4 inches every time the weight increases by 2 pounds. And that's the relationship between the two variables. So the slope is negative 0.4 divided by positive 2. Simplify that, gives you 0, negative 0.2. Replace, now I need to find the y-intercept. The y-intercept is the value of y when x equals 0. Do I have the value of y when x equals 0? They didn't give me that. And I'm not going to keep going back with the weight until I get to 0 to know what the height will be. So there's an easier way, faster way to do that, which is to write the equation, replace what you know, and I know the slope, negative 0.2, and I know what x and y are using one of the coordinates from the table. So I'm choosing 19 for the x and 10.2 for the y. Now replace everything you know in the equation. Y is 10.2 equals, the slope is negative 0.2. Replace x with 19 plus b. Now watch, you have only b to solve for. First of all, you multiply negative 0.2 times 19, gives you negative 3.8. Bring everything else down. You end up with 10.2 equals negative 3.8 plus b. Now I need to solve for b. The addition property of equality, add 3.8 from both sides. You end up with b equals 14, so the y-intercept equals 14. Now replace the b in the equation, y equal negative 0.2x plus 14, which is the y-intercept. Now we write those linear functions so we can use them later. What is the height of a bunny hop on a bike that weighs 21.5 pounds? You don't know what the height is when the weight 21.5 exactly. That's why we use the equation. So replace what you know again, try to find y. Since x represents the number of pounds, replace x with 21.5 and find the y. So y equal negative 0.2 times 21.5 plus 14 is 9.7 inches. Here's the last example for today. You and your friend are saving money to buy bicycles that cost $175 each. The amount y in dollars you save after x weeks is represented by the equation y equal 5x plus 45. The graph shows your friend's saving. So now you have a graph and you have an equation. The equation is you and the graph is your friend, and we're trying to compare. To answer the question, who has more money to start? Who saves more per week? Understand the word to start means the y-intercept, which is the starting value. You are represented by the equation y equal 5x plus 45. So which number represents the y-intercept or the b or the starting value? 45, because it's the number that stands alone in the equation or the constant. So you started with $45 in the saving account. Now your friend or my friend, finding the y-intercept from a graph is where the dot line crosses the y-axis. So look at the red dot, it's between 10 and 20, which means it's x is 0, y is 15, so that's the y-intercept, which means you started with about $15. So your friend started with about $15, so you started with more money than your friend. Now, who saves more per week? The word per means a rate of change, and the slope shows the rate of change. So now we're using the slope to compare. And you are represented by the equation y equal 5x plus 45. The slope is always the number attached to the variable x, so 5 is the slope. Since the slope is a rate between two things, the change in y divided by the change of x, make it a fraction. So put 5 over 1. And since the numerator is the y and the y is the dollar amount, so that's $5, x is the denominator, which is the number of weeks, 1. Which means you saved $5 per week. Now let's look at your friend. The slope is the change in y, which is y2 minus y1 over x2 minus x1. Use those two dots or the coordinates on the line, 3, 39, and 0, 15. Subtract the y's, 39 minus 15 divided, subtract the x's, 3 minus 0. Gives you 24 over 3. If I simplify that, is 8. So my friend saves $8 per week, which is more than you. Because if you make this 8 over 1, that's $8 per 1 week. In conclusion for today's lesson, y equal mx plus b, that is the linear function where m is the slope or the rate of change. We use the word per every or each to explain or interpret what the slope is. B is the y-intercept, also called the starting value. So use the word starting initial to explain or interpret what the starting value is. Use the slope and the y-intercept to compare two things, whether from table and graph, equation in a table, whatever you are trying to compare, you need to know how to find the slope and how to find the y-intercept to compare. That's it for today's lesson. Thank you for watching.